That was exhilarating.
So we were much closer this time, and we even managed to steer the rocket in the right direction just slightly.
We found it.
Good.
Egg?
No egg!
No egg?
Wait a minute.
It's the egg!
It's the egg.
Oh, did it crack?
I mean, it's not cracked.
So after 3 failed attempts, we still seemed pretty far off from where we needed to be, which meant it was time for the ultimate phone a friend with my buddy Adam Steltzner, who you might recognize as this guy from when we landed Curiosity on Mars.
Touchdown confirmed. Proceed on Mars.
He has a PhD from Caltech, and he's also the chief engineer for Perseverance and Mars Sample Return. And so after explaining to Adam what we were trying to do, he immediately spotted a fatal flaw in our brilliant plan.
And you're doing terminal guidance to something about the size of a house. How are you going to do that? How do you do that? I mean, I know how you physically do that. How do you not get busted by the FAA?
In other words, we were basically attempting to make a precision-guided missile.
Dude, there are thousands of people who have done this before, and they are sworn by federal law not to say a single word to you.
And to be fair, he raised a good point. The people who could help us actually can't, and even if we figured it out ourselves, the ethics of just slapping that how-to video up on YouTube are questionable at best. And so after a fruitful discussion with Adam,
But we release at about the height, and then we do a lobbing. The thing you start to worry about is heating. You might want to start with a 2-stage thing.
we decided to pivot, and instead of a precision-guided egg landing on a mattress in a small town, we would set our sights on a much more general egg landing target by heading out to the desert. But as part of the pivot, we completely scrapped our old design and spent a couple months designing and building a new system that borrowed heavily from the Curiosity landing, because we figured if it could safely put a rover on Mars, it could safely land an egg on Earth. So we would still go to space on a weather balloon, but this time the rocket would have fins that didn't move, and it would be 3 times as long and 4 times as heavy to guarantee we would get the egg to supersonic speeds on the way down. Then just like NASA separates the cruise stage in the upper atmosphere and then uses aerobraking to dissipate a bunch of the energy and speed, we would separate from the back half of the rocket about halfway down after we'd already broken the sound barrier, and because the system now weighed much less, it would naturally aerobrake and reduce its speed to the new lowered terminal velocity. Then on Mars, the next step is the parachute deploy, followed by the heat shield separation, and we would follow in kind by launching our own parachute and then release our own nose cone, which would then expose our set of cushioning airbags, as you can see here, which we borrowed from the Spirit and Opportunity landings. It was intentionally ambitious and extremely complicated, but after a couple months of complete redesigning and building, we found ourselves in the desert feeling cautiously optimistic. And that was due in part to our lucky orange parachute, because when I left NASA, my friends gave me this rectangular piece of nylon. And for scale, that's the exact same rectangle here that's part of the parachute the Curiosity rover used to land. So that piece of parachute is actually one of the 80 rectangles you see here as they were running the final tests in the world's largest wind tunnel. And so it only felt fitting that after some scribing, a bit of cutting, and a little sewing, it had nobly repurposed itself for the new mission. So as the sun went down, back at the hotel, we worked late into the night on final preparations. This was an idea and a passion project 3 years in the making, and it took a staggering amount of work even to get us to this point. We had thought and prepared for so many things that could go wrong, and while I was feeling optimistic, I knew at the end of the day, it was the laws of physics that would ultimately determine our fate. So early the next morning, the crew in charge of the balloon got to the launch site to start filling it up. And this balloon looks a little different than the others because it's a zero pressure weather balloon. The advantage these have over a typical weather balloon is they can go higher up into space, carry more weight, and they're open on the bottom, which means they equalize to the pressure and it's impossible for them to pop. So when you want it to come down, you send a signal that will pull down on a string that's sewn into the side of the balloon, and it opens like a zipper and self-destructs. The downside is they're incredibly lightweight and so thin and delicate, you have to be really careful and touch it with gloves. And they were about an hour into filling it with the 4 massive tanks of helium we had on hand when we made a gut-wrenching discovery. Hey dude, I got bad news. We have to scrub. Start taking the helium out of the balloon.
Launch scrub. They had some issues that I guess they can't resolve by today. So we're sucking out the helium from the balloon and trying for another day.